So this is where we're at. We're in this packet here. It's what I just passed out to you. So as soon as you finish your warm-up, what I want you to do is I want you to open it to page 2. You're going to see that there are 2 columns, okay? There is, on the left-hand side, estimated pH of substances on the left-hand side, and the actual pH of substances on the right-hand side. What we're going to do first is you guys are going to take a guess. So you're going to fill in this column over here, the left-hand column. You can see that I did it earlier. So period 1 made a guess. Their guess is that apple juice is about a 4 on the pH scale, and that milk was about an 8. So as a reminder, your pH scale goes from 0 to 14. I added a 14 to mine. It's like really strong bases and really strong acids can really hurt you. We are not going to be working with any of those really super strong acids or bases. They're like sulfuric acid would be like it is 0. Very dangerous. I can't even think of a base that is 14, but like even our oven cleaners, things like that, they're pretty strong bases. Neutral is at 7. The closer you get to 0, the more acidic it becomes. So these are your really strong acids. These are your weak acids. These are your weak bases. These are your strong bases. So what you're going to do is you are going to look at this list. It's up on the board over there to the side, and it's also there. You're going to look at this list, and you're going to make a guess where they go. So your guess goes on the left-hand side. What do you think the pH of milk is? What do you think the pH of apple juice is? Lemon juice, window cleaner, baking soda, vinegar, witch hazel. If you don't know what witch hazel is like an astringent. People will use it to like clean their skin. It removes all like the dead skin cells and all that from your skin. You have dishwashing soap, baking powder, rubbing alcohol, nail polish remover, pine sol, and ammonia. I want you to guess in that left-hand column what the pH is of each of those. Put them where you think they belong. I'll give you a couple minutes to do that before we test the actual pH. Go ahead and do that now. Well, 13 is a high base. This is neutral. This means that this is neutral is like water. Okay? This is more acidic. This is more basic. Here's a clue for you guys. Mark it for you. Acids are typically sour. Bases are typically bitter. Now, obviously, we would not want to check or taste a lot of substances to see what they are because they can really hurt us. But as a general rule, if something tastes sour, it's an acid. If something tastes bitter, it's a base. So that could probably help you to figure out what some of those are. So acid is from like 6 to 0 is an acid. 7 is neutral. Pure water is a 7. Bases are from 8 to 13. neutral, acids, bases. Where do those substances go? So is milk an acid or a base? What do you think? Okay. So you think it's a base. How strong is a base? The further you get towards 13, it's a stronger base. So these are weak ones. This is stronger. This is weak. This is stronger. So where do you think it goes? So you think it's a strong base. Okay? Where do you think apple juice goes? What's that? Neutral. That's all you're doing. And then we're going to test them. Get them all down. You have to list where all of those go. They're on these. Yes, ma'am. Yep. So you think that apple juice is an acid and it's right around here? No, I don't think those are good guesses. Because this is acidic, so this is an acid. Okay. This is neutral. This is pure water. This is a base. Okay. Come this way, they become stronger. Come this way, they become stronger. Okay. So take a guess where you think each one of those goes. It'd probably be easy if you write the names so you can refer back to that. You good? Good? Oh, why? Take a guess. You don't have to be right now. You need to take a guess right now. We're going to do the actual test to determine you're on the wrong side there. This is the actual pH. This is the guess.
What did the last one say?
Ammonia. 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 Guesses go over here. These are the actuals. So the guesses over here. You need guesses for the pH. Throw them down over here. You guys don't have to be right, but you do have to take a guess right now. Take another minute or so and finish that up. So what do you think milk is, an acid or a base? Okay, how strong do you think it is? You guys good? Just another few seconds and then we're going to go and we're going to actually start to test these. Okay? Guys, you have the list over there on the board. I'm going to put up the viewer so you can see the actual lab. Okay. So with our paper we have there. We have acids, bases, and neutral. I'm going to take two of them that are up there. I'm going to tell you that one's an acid and one is a base. Okay? We're going to use something different to test our pH today, but there are different ways we can test pH. Three things that we could use to test pH are what you see here. They are all talked about in that worksheet that you have there in front of you. We have pH paper, we have litmus paper, blue litmus paper, and we have red litmus paper. The first one we're going to talk about is the pH paper. pH paper always comes with a little paper here that is a color key that tells us what the pH is when we dip this strip in. So all you have to do is take and dip your strip in. You dip it in, and within 30 seconds, it's going to change colors, and it's going to show us what the pH of the substance is. So I'm going to dip it into this. This is ammonia, and you can see we instantly had a color change. Guys, I don't want to have to do write-ups for phones. I have enough to do. Put them away. We're going to take this and we're going to compare it to the color chart. So when I look at the color chart, if I look, that puts me probably at about a 12 on the color chart. And that's all you do, DeMarco, put it away. That's all you do for pH paper. Now, with red litmus paper and blue litmus paper, it won't tell me the exact pH. It'll just tell me if something is an acid or if it is a base. Jonathan, pay attention. Red litmus paper turns blue in a base. Blue litmus paper turns red in an acid. So I have ammonia and I have lemon juice. So what is lemon juice, an acid or a base? It's an acid. So if I put red litmus paper in an acid, it doesn't change colors. It just looks like wet paper. Put it away and pull your mask up. If I put it in a base, it turns blue. So red litmus paper turns blue in a base. So what do you think is going to happen with blue litmus paper? If I put blue litmus paper in a base, it should do what? Stay blue. If I put blue litmus paper in an acid like lemon juice, what should it do? Turn red. So blue litmus paper turns red in an acid. Red litmus paper turns blue in a base, okay? You're going to need to know that it asks you that in that packet because today you're going to finish pages 1 and 3 outside of here. So make sure you know those. Now you could buy pH paper like on Amazon. That's where I buy mine. You can buy litmus paper and that on Amazon. But if you wanted to do a quick test at home, all you would need is what I have here in this container. This is cabbage water, and this is going to be our neutral. What I did last night was I took some red cabbage and I cut it up. I boiled some water and drained the water off, and I have my pH indicator that we're going to use today. This is our neutral. So this is what our 7 looks like. Okay? Cabbage water is almost a 7 exactly. It depends on the water that you use. If your water is a little bit more acidic, it's going to have a little bit of a different color. If you look at this little slip here, can you guys see that? This is what we're going to use as our reference. So if it is pink, if it turns pink, that's an acid. It's going to be in the 1 to 2 range. A dark red is 3 to 4, so again, acidic. A violet is going to be a 5 to a 7. That's going to be slightly acidic to neutral. We'll be able to tell where they're at. 8 is blue. That's a basic. Blue-green is 9 to 10. Again, basic. And green-yellow is a stronger base, and it's going to be 11 to 12. So we're going to start, and in your right-hand column, what you're going to do is write down the actual pH. So we're going to start with milk. So all I have to do is take this cabbage water and put it in the milk, and it starts to change colors. Now, I will warn you that some of these we're going to have to talk about a little bit because on the screen, they look a little different. Gentlemen? So what does the pH of milk look like? What color do you think it is? Yep, it's definitely a bluish color. So what pH is that going to put us at? What's that? An 8. Your pH for blue, as you can see here, is an 8. So where it says on the right-hand side, actual pH, you're going to put milk as an 8. So on the line by 8, you're going to put milk. Now, some of these might be on the same line, so make sure you write a little small. Ready? This one is lemon juice. Lemon juice, acid or a base? What do you think? Acid. Strong or weak acid? Ever get it in the cut? Yeah. Give that a second, because that should turn a little bit more pink, I think. That definitely should. I wonder if I got some. Oh, that one was apple juice. That's why. I was thinking it was lemon juice. Thinking that should be a lot pinker. I flip-flopped them. But that's the violet, so where should you put apple juice? Probably around the 6, 5 or 6. It'd be in that 5 to 6 range. Lemon juice, you guys told me, is an acid. What do you think of that one? So I think that looks, that one looks more of the darkish red, and I'll tell you why, because when we do some of these other ones, you're going to see that one of these is darker. So I'm going to say that's probably at about a 3. So I'm going to say vinegar is at about a 3. We got window cleaner. What do you think window cleaner is? Like I just got a bottle of Windex out and put a little bit of window cleaner in. What do you think? What's that? The one in C is lemon juice. This one is window cleaner. Where'd you have window cleaner? Yeah, that's going to be a violet. So probably at about a 6 or so. Window cleaner is slightly acidic. And I think it's because a lot of window cleaners have vinegar in them. Now, baking soda, we're going to have to, and guys that are close here, I want you to look at the screen on my computer because it's going to look different than what you see up there. For baking soda and baking powder, the colors are a little bit different than what they appear on the screen. So lemon juice was here at C, and we're putting that at about a 3. Paris, can you see the difference here? And or could you guys, you girls, can you see like either on my computer screen or by looking here? Can you see how baking soda looks? It's different than on the screen there. Yeah, it's like I don't know, it looks like it's kind of going towards that teal color. So what do you think we should put baking soda at? I don't think it should be at an 8. Well, I think it's going more towards this blue-green, so probably a what? Well, look here. You're right here. Yeah, I think about a 9. Sorry, guys, I'm doing the best I can. This was the best solution I could come up with so that we could still do the lab. Because I like this lab for you guys to be able to see pH. So we are now on to vinegar. What's vinegar? Oh, no. Vinegar is it is pink, so it is an acid. So that's probably going to be in that like 1 to 2 range there. Can you see the difference between the pink and like that reddish color that we had with lemon juice? G is witch hazel. That's that astringent that you can use to clean your face. That's more of that violet color. It looks kind of close to what we had here for like D, which was our window cleaner. We're on to H, which is dish soap. G is the witch hazel, and I would put the witch hazel right by where you put the window cleaner because they're pretty close. H is the dishwashing soap, like for the dishwasher. And that is, it doesn't look like, I don't know if you can tell, it's a slight difference. It's a blue. Yeah, it looks a little different. It's right around where you would put the milk, so around the 8 range. So dishwasher soap is right around the H range. Which is the dishwasher soap, and it's going to be right around the 8 range. We're going to do I, which is baking powder. There is a difference between baking powder and baking soda. We'll have to let this one set a second though, because again, it's a powder and it's going to fizz up a little bit. Okay, what do you think for that guy? Remember this one that we said was teal. I know you guys can't see. If I turn my screen a little bit, can you guys in the back see that like this is more of a teal color here? If you look, this is more of a blue, but it looks like it's between that blue and that teal. So I'd probably say that it is right around, where'd you guys put E? Did you put E at a 9 or a 10? Okay, so then I'd say if you put that one at 9, this one would be an 8.5. If you put this one at 10, you could say that this one's a 9. That one was baking powder. There is a difference between baking powder and baking soda. Don't exactly ask me that. Maybe we need to ask Miss Jones and Miss Anarelli that, because I know different recipes call for different things, and some of them make it rise more or less, but J is rubbing alcohol. Like if you get a cut on your skin or you need to clean your skin, like before they give you an IV or something, they put some rubbing alcohol on it. If you look, this looks pretty close to what we had here with D, G, and J, which would have been our window cleaner, our baking, our witch hazel, and then that would be the rubbing alcohol. How about nail polish remover? What do you think? What's your guess for nail polish remover? Give me a guess. What do you think, Dawn? What's that? Okay? Did anybody, is everybody in agreement that they had it as acidic, or what did you guys have it as? Acidic or basic? Acidic? Okay. What is it? It is basic. It's probably that 8.5, 9 range. Two more to test. I'm going to have to slide this one out so we can get everybody in though, okay? This one is pine salt. That surprised me because a lot of your cleaning supplies are going to be basic, and pine salt is more what? It's more acidic. That's a pretty good pink there. So that puts you up in that what range? 1, 2. Okay, guys, phones should not be out. We should not be playing on the phone. M. M is ammonia. We already tested that with that pH paper, remember? So what is ammonia, an acid or a base? Nope. It's a base. Look at how much of a base it is. It's a pretty strong base. So if you look that up here, where's our ammonia going? Yeah, it's 11, 12 range. It's a strong base. If you ever smell ammonia, you'd get that it's got a really strong smell to it. Okay, I'm going to do my best to put these all up on the screen. Along with that there, I'm going to put it that way because I don't know if I can get it in. I can get it in. There we go. Okay. Make sure that you have the actual ones down. Again, this counts as a lab. There are the front sheet where it is fill in the blank, and the second sheet is going to ask you things like, is it acid, base, or neutral? So like number 1 on the 3rd page says blue litmus paper turns red. So when blue litmus paper turns red, is that an acid or a base? Okay, when we put blue litmus paper into something and it turns red, Angel, it's a what? It is an acid. So on the line there, you would put acid. Down below is the pH scale. You need to label that pH scale, where it is acidic, where it is basic, where it is neutral. And you need to label strong acid, strong base, weak acid, weak base. On the front is simply fill in the blank, but again, you need to know about that litmus paper like we talked about when we started. Okay, you guys have a few minutes left. The chart on page 2 should all be done, so you should be able to start on the rest of this. It's due tomorrow. Questions?